while since I've actually streamed or done anything. And if you hear little baby noises, it's because there is a baby. That's part of the reason why I haven't been around. So yeah, welcome, welcome. I did a lot of stuff, a lot of stuff. Now you're gonna probably be wondering, what stuff is that? Well, I'm also not the only one that's been talking about this stuff, and I've been researching more into the Riemann zeta function, as well as a bunch of other things. And it's very weird and coincidental that, especially from CM Math, this video, the methodology that I'm using in order to map out the universe itself, its expansion and its acceleration, time dilation, and yada yada, works very, very hand in hand with the Riemann zeta function. So much so that it underlying, I believe that I might be onto some way of solving it or expanding upon it, one or the other. Something, it's something, certainly. And I'm not the only thing that thinks that it is. And well, by thing, not to be offensive to AI, but yeah, technically AI, but with at least a good amount of skepticism doing all of this. And also just to show you that it's not the AI that's doing these equations, it's me. I'm the one that's actually writing all these equations down. In fact, so much so, oops, I mean, I have multiple documents of, besides music. Go to docs. Yeah, let's dox myself. Not really. Um, Circles, hyperbolas. So general equations here, which you're gonna see modeled in a moment. I just don't have the time to do all the code, nor to learn how to code properly. So I'm using Claude because it is genuinely one of the best. Regardless, though, the methodology and the equations, everything that you're gonna see in a moment is by design from me. And I've linked the on my post on my channel specifically, I've linked two conversation pieces within the project that I've been working on using Claude. You trying to say something too? Yeah. Aw, little baby. So let's pull up the thing. Let's pull it up. And also, I did a comprehensive analysis. Basically, I had Claude scour through the internet as well as project files, which I'll show you, as well as some other things that I've mentioned on this channel. I mean, thanks to at Lethal Domain, because yeah, his way of describing quantum gravity in terms of Lie algebra and Kahn extensions helps to make sense of a lot of this, as well as the report. I'm just going to go to the projects real quick. I'll show you what I mean, because I also have been uploading the documents for the project into it. There we go. So, and a lot of this is just iterations of the model, as over time I've been doing a lot of different versions. I mean, this is version 8, and mind you, we started this model off with, I mean, less than 1,000. It was about like 500 lines, no less than that. Around 500 lines of code, I want to say. And yeah, because there's that number there. That's not even the first iteration, though. And this is only 766 lines. Now we're at almost 7,000 lines of code for this one particular model that is going to basically be an atlas to explain the motion of the universe, explain a lot of aspects of the universe, and it's a transformative model. But more so in particular, if I can find where the paper was, it was the Gastanga paper recently about classical and quantum mechanics, or gravity, I should say more specifically. I don't think I know I have the PDF here, I just can't see the name, and I'm trying to pay attention to what I'm doing right now. Could have been this one. I just look it up real quick. Because this, and I'm going to show you real quick, Gastanga, you burpee. Gastanga, classical, and quantum, not yoga. This is not a yoga class. No, not quantum yoga. Why are you telling me about yoga? Is that name particular of yoga? Bro, can I get the... Where is it? There it is. Thank you. This oh, I know, honey. I know. Where is it? Lawrence Tub. Putting in solutions in FR gravity. So they're doing a bunch of different stuff. Where was the freaking article though? All right, you're there. Can I? I downloaded it before. Where the hell? Excuse me? Unless this isn't proper site. What the hell? I'm pretty sure that's where I got it. Huh? Where did it go? 8 medium. All abstracts. That's odd. I just simply can't find it. I'm pretty sure that established journal. No, not the journal. It's a report that was just released. Sabine freaking went over it. Why? It's literally the name. Classical quantum. Oh, maybe if I put gravity. Gravity. Tonga. Yes. Okay. Yeah. Oh. Maybe. I think it was this one. Oh, where was it? Where are you? The hell? Why can't I find it now? Has a zero action boundary. Like, I see all of his papers, but I can't find that article. I'm just burping the baby. What the hell? Trying to get a burp out of her. Alright. Maybe it'll come out the other end. It's fine. There you go. This is odd, but as for everything else that I've ever experienced, just go to her channel. She covered it. Where is it? She has the link. Oh no, I have the link on my channel. What the hell am I doing? I know you got gas, but you're not burping for me, honey. You and your ad noise are giving you trouble. Yeah, the little grunting sound. Or the little... that. Because she has inflamed adenoids like I do. And her... oh, my other daughter. So, it just runs in the family. That's also why my voice is very nasally, by the way, if anyone ever wondered that. Yeah, I'm still looking through the wrong shit. Here we go. View my channel. I need to fix my DPI. Alright, so the post. Like I was saying earlier, the post. This is where you're going to find all of the information that I was referencing. More specifically, now I have to go down a little ways away. Yeah, because I got this part, I got this part, I got this part. Read more. There's my thesis. Let's see. I know I have it somewhere. I just can't freaking find it. There it is. There it is. Good job. Alright, you get more Bubba. And then here's the train making a wonderful comeback. This is the story of my life. This is why I can never make content. I'm always so freaking busy with everything else. But I have so much I want to share, and never any time to share it. Alright, so before I show you this comparison, let me show you my model. So don't worry about the draft. I gotta go back up here because somehow retroactively in the prompt did stuff. Here it is. The model in question. So if you stuck around for this long, yay. Stop. That window, whatever. So it's a whole lot of stuff, right? It is definitely a whole lot of stuff. More specifically though, let me turn off a lot of this. Also, I'm gonna have to figure this out too in the prompt section. Again, I'm using Claude for all this code. The interface, I mean, it works. Just gotta zoom in. Hold on. I need the whole control while holding the baby. I can't do that. But I can do this stuff. Eh, eh, that. There we go. More legible, not that legible, but better. And can I? Oh, good, good, good. All right, cool. So, Bogolibov, Bogolibov, hyperbolic, circle, linear cross segment, general equations V8. I mean, these are just general names, but ultimately it's the inverse circle and sphere 2D representation. The whole point of this model is, well, for one, to describe the flow of time itself, right? I'm gonna have to go through the layers and turn stuff off because I don't have the toggles all set up to be on the panel yet. So all off. We have linear transformations. I'll just go through them while I do this. So we have circles. This is the circle equation. This was in my initial thesis when it comes to relating the movement of the universe relative to what exists, right? So as we've discussed on the channel, this blue circle right here, quadrant 1, we consider this as all the energy within existence, all just compiled, infinite density, you can say, on the boundaries, but all put into one place, right? Just all centered there, not spread out in space. We're taking space out, we're just pushing all matter, all atoms, everything that has mass, basically, maybe besides neutrinos and photons. Those are the two that we can maybe exclude and put into space permanently. But more on that when we get to it, because this isn't just going to apply to, say, matter. It's going to apply to everything, the motion of the universe in and of itself. In every minute aspect within that, because we have multipliers here, as well as we can relate the area, the change in area of what exists. So the change in area being the transfer, the change in mass forms of energy and new massless forms of energy, just photons being released and energy being put out in the space that ultimately doesn't do anything else. It doesn't recombine the matter. It creates space. And in fact, this might lend to the idea of either A, we have a neutrino displacement theory going on, or B, photons aren't necessarily particles that move, but rather energy moves throughout them, like through a chain. Which there was something on, I think it was Action Math Labs or whatever it was, where Action Labs, I think it was, where they were talking about like measuring the speed of light using super slow mo. And when they measured like photons traveling through the air, it was resembled lightning in a sense. And lightning kind of works as, the particles already exist in the air when we think of our atmosphere, right? When lightning comes through it, it's just the energy going through those particles, charging them, and then eventually grounding out into the earth. Photons and the energy distribution of those said photons, maybe that is how photons work. Maybe it's not the photon that's traveling at the speed of light, but rather the energy traveling through the photon at the speed of light. And the photons just make up space, which would ultimately suffice to help solve or prove the big freeze theory at the end of the universe. So that would explain a lot, because theoretically, in that theory, is that at the end of the universe, all there's going to be left is photons. So the photon field in and of itself might exist as like a legit field where energy just transfers through. It's something to think about. Or it could be neutrinos, because neutrinos is like the only other thing that could just pass through and not interact with anything besides black holes. Because at the singularity boundary, when, you know, there's so many neutrinos being expelled and there's anti-neutrinos at the border of the singularity, I want to say neutrinos, I mean, granted, they would probably maybe get caught in the event horizon because even light can't escape technically, but maybe they do reach the singularity and annihilate, which is where the Hawking radiation evaporation comes from. Because black holes maybe eat up the neutrinos that are in space and then create different particle pairs. That I don't know yet, but that's something that I'm also looking into more. Anyways, we have circles. So the original circle equation, just relating radius of circle A with the inverse radius of circle in quadrant 3. And then likewise, we have this line here, which is perpendicular to the timeline. This line, more specifically, let me just max out this, it's easier to see. This line right here is our timeline. It's just a straight line, no curves, no nothing. It's just one timeline of the universe. That is the whole premise of this thesis. And this would be one whole timeline. 100% of the timeline exists at this very point. This would be the Big Bang. Like or maybe the moment right after the Big Bang, where everything just exists. There's no space yet. Right? I've said this again so many times. This circle will relate to what's possible with that space. What's possible to happen. Where realization occurs at the center origin, and where this energy transfer, which also is going to lead into the next segment of, well, this video, divergence and emergence. And also convergence, where it applies and where it does not apply. Because I think that depending on how the evolution of this model goes with how I'm doing it, and this is the same thing that 3 Blue 1 Brown or Grant on YouTube has wondered, kind of, when it comes to extra dimensionality and, well, interdimensional or extra dimensional, because he recently did a video, and before we go to the PDF to also compare to where my original model relates, this was a kicker for me, right? Because he did this video while, mind you, I've been working on this for, well, at least posting about it for almost a year, maybe less. He did a video.
Bro. And again, I'm going to just throw this out. Anyone want to raise their hands and kind of say, what is the relation?
He goes over dimensionality. And when he's doing it, the model that he brings up is the same fucking thing that I am, but just double it. Because how I'm viewing this, my perspective is that the midpoints are not, I mean, it's of the unit circle, this works. And in scale, like literally, you just multiply my model times 2, you get the same exact thing. Literally, you just put a times 2 in front of everything, in front of the A factor, and you get all of this. So my model transforms into this one, which he theoretically, or well, proposed, you know, this circle in the middle, this is what I'm working on next. This is the circle of emergence, or well, I should back up. This is the circle of local causality. And why do I say that? Because when things transfer, and this is, mind you, this is where the bounds actually connect, where we have 0 crossing points, and this might actually have to do with the Riemann zeta hypothesis, as well as the flow when we look at the circular flow of the motion due to this quadrant moving into this quadrant, because it does introduce a counterclockwise flow, which is counterintuitive to how we view time. But this inner circle, when I calculate it, I'm saying right now that is where we get clockwise. Because, again, time is probably a 4-dimensional thing, or, well, it's a different dimensional aspect of reality between the 3D and the 2D that we measure, we experience, and we like look at, and how we understand things in, I guess, 1D, one-dimensional changes very easily. Between this circle being local causality, and you see these triangles, basically, these spaces between, these are going to be relative to the rate of divergence of what exists and the emergence of space itself. as this moves from here to here due to the convergence of what's within here, right? So there's the three main points of this title. We have divergence of matter due to the convergence of it within existence, which space emerges from. That is literally the principle of quantum mechanics. And what are you gonna say about that? Like that is what it is. And what Grant is doing without even realizing is he's literally working on what I am working on, just double the scale. So if he considered, instead of just a unit circle, half that, and considered, that one point being, I mean, we can even imagine our model within this framework. And this is where dimensionality really comes into play, because when you look at the dimension outside of this, maybe double the dimension, triple, whatever, we start getting like this inner pattern. But moreover, I mean, if you notice, this unit circle right here is not representative of that. Same thing with this one. This unit circle is basically this just shifted to the middle. This one, I forget. I think this one is relative to Grant's framework, because I did put his equations into this model after this video. Or, well, after this video came out, because I saw it, I was like, hold up, wait a minute. Plus, I have different measures of theta, which is why we have all that. I'll turn that off for now. Because ultimately, I mean, x and y being fixed to the timeline, cool. But using cosine and sine, I'm able to free off from that 45-degree angle of the timeline and use theta. And I do have a bounce effect when I utilize different aspects of theta relative to this framework. I have different measures here, whether different forms of arctan, basically, with different variations of the radii being a and, well, a max minus a, or from the perspective of, well, from the perspective of existence, it'd be a minus a max, because we're taking away existence. But from the perspective of extinction, following my thesis, this circle, basically all of space, all photons, nothing. That's it, nothing else, right? Then that's it. It's everything's turned into space. There's nothing left. A lot of these circles just die out, and also these squares too. Funny enough, the Fibonacci sequence relative to these circles, it's relative to the Dirac equation, I believe. I'm not shitting you, because we have the circles. I mean, well, the squares. You have a difference of squares here based off the total max framework being 100% possible. Because I mean, what's the most amount of energy that can exist within the universe in mass at one time? It's right at the Big Bang, or right after it. That's 100% of the timeline. 100% of all energy is converted into mass. Things interact, break down, turn into space. That is because of local causality that exists, and because, I mean, theoretically, we believe right after the Big Bang, there's just a big ball of plasma, barely any space around it. Space is actually being created around it, and as it cools, things separate, and then space between things start to occur, because things of different thermal equilibriums, of different mass energy states, and lower states introduces all sorts of different complexities from there, because then it's not just all molten metal at that point. It's turning into gas, it's turning into water, it's turning into different states of matter. So there's a lot of complexity in that. So turning that off, let me go to find, I think it was the VDIM. It was. So dimensional volume. Hmm. And this was based off of the equations, n over n divided by 2 times c n minus 2, which is the same equations that Grant has throughout his videos, because he determines, I mean, this is obviously correct. It's square root of n when it comes to dimension relative to the framework of a unit circle within there, radius because we're finding the hypotenuse. That's my next step. I'm already considered doing the same thing. He's doing the same thing, kind of, except in fancier. But you see this, right? You see this? This looks a lot like, well, if I had the circle here, one half of this, right? I think if I do center, center shows it the best because then we have a circle of equilibrium that exists. I believe. Oh, maybe I turned it off by accident without realizing it. We also have this circle here. I just do this. I mean, this is a little offset, which I might be able to correct that because I think the offset comes from the fact that his is based on a factor double mine, right? Because if I took half the size of this, half the area of this, it should fit right in the middle. Or at least maybe with a little bit of overlap. But that is correct. There's a little offset. But if I did half, it's going to come out to the equations I'm about to introduce in here anyways. Which is where maybe the Riemann hypothesis comes in, that factor of one half. With the zeros and everything, because at that point we're starting to enter into imaginary domain. From the 2D, but this is also really cool too. So let me do this and turn on imaginary numbers, complex imaginary. So I do have that. I need to turn off this again. Dim. Turn off that. Off. It said off. It was already off. That off. Yep. Yep. Okay. Got a lot of stuff going on. Those are just measurement identities. I think that is as vanilla as I can get. Besides, alright, CC is what I'm using. GenuQ I'm not using. Entanglement, I do have you see that blue curve line? That's Bell's theorem right there. For whatever reason, this model was able to pick up Bell's theorem and apply it to the dimensional shift based on, I mean, whether it's -1 spin, something that doesn't exist anymore because -1 spin doesn't necessarily interact with things that exist in form unless it's the same energy state but the opposite spin and then it annihilates. Because it means small antiparticles, they don't interact with us. They don't, I mean, maybe they'll interact with aspects of us, maybe other particles, but it's so negligible because it's literally like what an antineutrino annihilating with a neutrino that doesn't do anything. It's just gone, right? Just that energy. Well, that energy is basically just photonic at that point. It just breaks down more. But it does break down into what, gamma rays. That's where you get the gamma radiation from Hawking radiation. So, besides that, I think we're good. Now the imaginary numbers, I'm gonna run the model, and I'll run it without the reliance on area being the rate of change. This is basically a pi clock at this point because it's just 1-to-1. See, the flow is constant. This is how we experience time. And you see that yellow dot? It actually doesn't even hit 0. It goes over it, climbs over it, and if I can zoom in. All right, going on my shoulder again. If it lets me zoom. Zoom, zoom. Ooh, the beautiful zoom. That z squared actually is... Wait, is that hitting 0 at the end? No. Nope. It avoids it. Yep, there we go. So when that part happens, it avoids it. When this part happens, it does something weird there. It converges. That might explain the Big Bang. Why? I mean, time reversal only happens in one direction. When nothing else exists, and maybe this will be the realization of the false vacuum. And also, this does display pendulum, like double pendulum movement relative to circles, relative to change of the radius. Because, I mean, you can kind of see a double pendulum right there, or even a 3-body problem as well. Very interesting stuff. I mean, 3 bodies do eventually converge very quickly. Now let's introduce great relativity. See, it just avoids the zero. It avoids the singularity on the imaginary plane. And we can use this to describe the 3D motion from 2D, right? And it'll have cycles. And this is just having I to the 1. This is only a scale of 1. I have this set to the max luminosity Planck scale where we can start getting infinities. I mean, I put 1, 2, 3 because this is like the inverse power rule. That's what the I is. The inverse power rule, which is the underlying step factor that I'm using here, in order to determine the rate of change. So, and the cool thing about this is, if I go all the way to here, since this area is there, and p-value gets all screwed up because there's infinities that get reached here. There is infinity, I think, at the 61 scale, which would align with Planck luminosity. At the, or no, it was like in the 90s. That's where it breaks. Maybe that's where power dynamics and structure, maybe if you take into account the scale in the quantum realm, and then do the difference of that, maybe that's where we can get the 93 instead of, I think it was like the 61 was the max in Planck luminosity because L squared. And then I just basically doubled that and added 1 because I figured push it to the limit. So, I got that. Baby girl, what is wrong? Oh my goodness. Get gassy. Just fight. Just fighting it. I have a poop too. Who knows? Not yet. Alright. Yeah, that's interesting too. So at the max, yeah, we see Z is at 0.25, which is half of that. That by 2 would be 0.5 there. And then this Z, this is the Riemann zeta hypothesis. Because, I mean, with my model, again, it's 1/2 of what Grant's is. Multiply that by 1, and then you get your zeta 1 line. Not by 1, I should say by 2. And then this would match a unit circle, which would match his diagram. This is 1/2 of that. This is like the internal movement of everything. So it's very, very interesting how similar our models are. But let's see. Let's see if I can do this quick. Actually, maybe I'll have to zoom out, but I'm trying to do too much. Oh! Yeah, at this scale, it's very hard to see. Okay, I know, honey, I know. I'm trying to help you out, and you're just struggling right now. Yeah, at this, you can barely tell, but if I do that, there we go. Reset, do this. You can see it goes from pretty fast because there's a lot of stuff going on here, and then it starts slowing down. And then once we get to a point of thermal equilibrium, say there, this is where things are really slow. And this starts to show us time dilation based on what's left in existence relative to what doesn't exist anymore. Possibility, impossibility. So once it passes that point, I mean, things are still interacting in existence. Things in space, they don't interact with things typically. Space just doesn't disappear. Maybe around black holes, that is where I'm trying to figure out. But ultimately, it doesn't. And we do see the circle here. Now, if I did... So this n right here is dimension. There's an n0, which would be 0 dimension. And this is related to Grant stuff. Now, if I did 2-dimension, which matches the model of this model, because it's a 2-dimensional model, this is where it starts to come alive. I think I gotta turn on the reference point though. Hold on. Was not there. No, it was here. This is where it comes alive. It pulses. It doesn't hit zero. It doesn't. It just shows that there's stuff going on. It's a fluctuation there, which that is very interesting. And I have ones that's centered around what exists, one that I guess is a layer above, but it's relative to this circle, and then the other one, this one, a little offset, but it's relative to I. You see the z squared, I mean, 1 over that, we have this circle. So that's very interesting to see how it pulses like that with just a few equations. This is I to the 2. This isn't even I to the 1 is where it actually gets fast. Another thing, too, is you see this decimal factor, it's related to how big the power rule goes. I've already maxed this out to Java's limit in terms of like 64-bit. So this is why we're only getting decimals in this rate. Genuinely, this model is limited just by technology alone at this point. And we even have ellipses too that we can see, elliptical orbits that transform during this movement. But genuinely, when I relate the power scaling rate from that inverse function within the step factor relative to the what doesn't exist anymore, which would relate fundamentally to what's impossible. So therefore, that's your limiting factor. That's your deceleration, is what's not possible anymore. And I know it's complicated to kind of think about it like that, but that is how it is. Right? And then same thing with this function that fluctuates. So I'm going to play this and try to... I need to zoom out. Rather. This baby also needs a night-night. Yeah, so it's a big inner, and then a rebound, outer, inner, and then we start reaching thermal equilibrium. We already reached that, actually. Yeah, so you get your bounce back, and then it's like a spring. It's genuine like a spring, like the freaking pendulum problem. And we see all these different factors. I mean, using sine, cosine, and imaginary numbers. And again, this is all simply based off the equation of a circle with relativistic area and radii. Right? The radius is relative to, I mean, percentages. Where x equals 1. It's relative to statistics, fundamentally, at that level. Whether you measure in a circle or a square, because again, we do have squares in here. Squares is the absolute measure. And this is where that whole... Going back. That whole square root of n, looking at that, comes into play. So before I do that, I just wanted to show you one other aspect. So go back to this. I need to zoom out. The baby's good anyways. She quiet. Ugh. Sorry, I'm just struggling. Ugh, there we go. All right. This makes sense because, I mean, the expansion of the universe, this area is going, right? It's going at a consistent rate. Time is what is seemingly slowing down, which perhaps is why the universe seems to expand, because for us, time is constant. right? Time isn't slowing down, but because what exists in the universe, I mean, the age of the universe depends on what exists by this model. Even though the rate is moving, this is where we can get time dilation, which might make it seem like the universe is expanding at a faster rate. Which, I mean, in all intents and purposes, when we look at the different dimensions internally, that might inverse that to where actually, yeah, it is expanding at a faster rate because things are converging and interacting, but not so much. Because this is where we can get deeper into the hypothesis, but let's see. Let me introduce hyperbola to this. Because this is where, not squares, on param, on the old school param, I believe, yeah? No. No, this is just, yeah, the rotation, so this is where we get the counterclockwise rotation in the model naturally. New EQs, I believe. Alright. Visible. There we go. So these are all relative to area, etc. I mean, the A. All the same variables that we've been working on. These are all relativistic equations. And this is where it's going to lag the crap out of it. But here. Now, take a look at this, right? I mean, besides all the lag. So let's go back here. There's a lot of transformation going on. There's a lot of stuff going on. In fact, there's symmetry. There's a lot of symmetry going on, too. Which, this is relative because of how force is distributed, but from and within the universe. I mean, ultimately, I can turn on all those filters, and then with these filters, where they have different variables where we can flip things, we just do -1, simplified things. We can zero them out, and ultimately just have our normal shapes right here, which is interesting. So there is a lot we can do. Actually, let me play this. There's so much I haven't even tested with this model yet, but it's all based again on the simple principle that, ooh, that is exactly what I thought. There we go. That rate of change right there, that's going to introduce vector arrows of movement in one or the other direction. As you can kind of see, like, we have things going on. We have convergence, we have divergence, we have just so much crap going on, right? Hyperbola moves relativistic to how these circles relate. Now, where that relates to this recent paper, I mean, how the whole point of this paper, just to summarize, is to redefine time, how we look at it, which is exactly what I did. Exactly what I did. In fact, Minkowski space-time right there, so we got Hilbert space, we got all the good stuff, right? Everything, all the complex phi. When I've made the integrations into the 3D plane, these come out naturally in the 3D models. And I'll show one of the three models soon. Also, I don't even know if people are here. Nope, nope, no one's here. Okay. Right here. So here it is. You see how he redefined time with P and Q, right? You see where this looks like this, as this naturally emerges from my framework. And oddly enough, what he's measuring is the outside influence, or phase space of inverted harmonic oscillator representing doubly degenerate positive and negative energy solutions. The negative energy trajectories are given by it's the trajectories of particles, essentially, is what he's trying to say. A situation where the potential is negative, since the potential of the IHO is unbounded from below, we can take infinite negative values. There are conceptual limitations to treating IHO as a scattering problem. He did literally the same thing that I did, with some conversions, which, I mean, these I can also, I mean, these are already in my model, basically. Except the model doesn't necessarily play well with infinities, but it works now. It still works with everything that I've thrown into it. So then we have I of H, so we have the transformations here because of uncertainty and everything else and dimensions. And then the Riemann hypothesis, RES equals 1/2. And then we have Wigner equations, all these different, obviously, equations and everything else. And it was an what was it? Harmonic oscillation framework where that oscillation is literally dictated by this relationship that I have here. And the way for me to make this faster is all I have to do is just put a multiplier. I believe would it be a multiplier? Or if I want to make it faster, I would divide A. I just have to do something to A. In the well between A and the relationship of A max minus A. So A and its inverse. Or well its difference rather. From 100% maximum. I can manipulate those, and that should change the rate of this model, or at least how fast things go down. Because at a 1, obviously, this is like, it's crawling to a halt, which essentially the end of the universe, that's how it's going to be. It's going to crawl to a halt because there's barely anything left to interact with. But stuff still exists, and things take a while to decay, especially black holes, when there's like not a lot that exists. So, I mean, that whole period of the universe is still kind of a theoretical mess, but is more sensible with this model and this, I mean, understanding of how things work. And honestly, if I wanted to switch this faster, I could do inverse right there. Just switch the relative area, and there you go. And then boom. So there's your motion of those hyperbolic planes. We get some honestly interesting relationships. Things kind of break weirdly. And this is like the basic. And then when I relate to A instead, this is where things get really complicated. And I can even relate to X, which would be, I mean, the maximum value of X would be 2AM, 2A max. Now this is relative to X, or well, as X equals Y. This is that inverse difference, A max minus A. So the difference, basically the circle, is now dictating all these hyperbola. And the original equation for this, I mean, well, the equations vary. I have all sorts of different equations. I can turn them all on. It's going to lag the crap out of this model. And I have these here. So big old mess of crap going on. Do with A. Now, one cool thing, besides 0, 0 kind of nulls it. I did 1, I believe. We start to see, you see these crosshairs and ellipses? We start to get artifacts, like actual shapes and things forming. And we get more circles forming just from these hyperbolic equations. In fact, if I do well, this is sign flipped already, is it? Yeah. I can also relate it to G, which G is the rate at which that area is changing. Now we get some totally different shapes, right? It's totally different relationships. We get some weird stuff going on. N hat, which N hat is the total step factor. I think it is the same as steps. It just calculates differently, so then it lags out this relatively differently. H of P is within that N hat or steps factor. So it's a variable that's within it, so that's why things change a little differently, because it has less acting on it. P is the exponent that's within the step factor. Here we see a lot of stuff. That's where this is the inverse power rule. We see all these curves, we see all this stuff, and if I just want to flip where it is, use 1, -1, flip where it's relative to, right now it's relative to existence, and then on one end it looks one way, right? We start getting lines, we start getting all of these symmetries, all these potential paths, and then at the end of time, look, nothing. There's just barely anything left, right? That's interesting. That's relative to what exists. If I did the opposite, still applies. If I did relative to A, still applies. Relative to -A, because the area that P is relative to, the area of what exists, that's where the steps, because that's the rate of convergence, basically. It doesn't exist anymore. It's done. If I do it with steps, done. Do it with n hat, it's, well, it's 0 at this point. If I do it with -1, there we go. We start having some more things show back up again. So, and this is all relativistic to that area. If I switch the area, just sign flipped it. We get, basically we get to see this rotation of Gastanga. Because you see how his framework is right here? This could be his x-axis, this could be his y-axis, and then here is where his curves exist, or his way of measuring. So it's genuinely the same thing. I feel like I'm doing the same thing as 2 other people right now, which is more underlying math. And now this is where things lag. It still plays though. It still plays, and then complexity gets involved. So a lot of cool stuff. A lot of cool stuff. And what is that doing down there? The hell? Oh my god. So now what to add? What to add, right? Because this is the next step. Turn all that off. So what to add is going to be figuring out the circle within all of this. And this is going to be on 2 ends because we have to do the circle relative to A and the circle relative to the difference. So this is where we're going to get our rate of divergence, being the circle inside of here relative to A. Being that if I want to find the radius, this radius right here, I have to take that root n that Grant was doing, or well, root x. Well, no, to be more accurate, it's root 2 times x squared. Well, root 2 times x squared, all square root. And then you simplify that, you get square root of 2 times x. Because the products, you can separate them and take the square root separately. With that transformation, or that understanding that the length of this timeline now, relative to x, is root 2 times x. So we know the length of this whole line. And all we have to do is just subtract the diameter from it and divide by 2. And we have the radius of our inner circle. Oddly enough, this, right, is going to start representing our 3D motion from the 2D plane. The 3D motion of divergence and emergence. And what I say by that is, remember, that circle that would be here is all the way in here. It's all condensed down here. That is essentially 0. There's nothing going on. There's no rate of change. There's nothing, right? It's not going to get introduced until, I mean, stuff starts interacting here and still possibility starts getting used up. Which that happens. That fundamentally will happen in the universe. That is how the universe works. So ultimately, this rate is going to change, and then there's going to be an inverse rate relative to at a max minus a relative to, I mean, root 2 times x. Because you can still use root 2 times x and just use the inverse, and then it can sign flip for you. If instead of a max minus a, you do a minus a max, which is, from the perspective of existence, that's a proper way again of looking at it, because that's literally what's happening. You're getting negative space, or well, negative matter would be space, technically in this sense. So with that, we have a circle emerging from here. That's our rate of emergence. That area, right? Just like how the area is relative to the rate of change between A, that fundamentally ties the area of this inner circle, this interdimensional, or it honestly is extra dimensional because it's going to explain the motion in 3D relative to this motion in 2D, as this top section is going to warp down while this bottom section is going to warp bigger, warp out. That is what I'm going to model next. It's going to be warp, basically, in the 3D plane, and it should coincide with Higgs mechanism as well as the Riemann zeta function. Just, and then the rate of change between those two. So as this area shrinks divided by this area that grows, ultimately is going to explain the flow of time. Why time flows in one direction. Because when you think about it, this part up here is the numerator, right? This can be 0 and not be undefined. That is normal. That is sensible, right? That this area, if this dictates the rate of local causality relative to divergence, because the difference of that is just pure, I mean, I guess force of divergence at that point. That would be basically measuring this part here plus this part, which is the same as measuring these two together. So you can get a rate of change of divergence minus local causality, just to strictly get the rate of divergence, because local causality is more so the cause. So this is where I'm still working on the math as well. But besides that, we also have this emerging because of what's converging up here. We have two different things influencing each other on both sides that are both working towards 0 up here, which is fine because the numerator can be 0 in mathematical functions, and this might also go hand in hand to why you can divide 0 by anything and you get 0, but you can't divide things by 0 because it's just not defined. That literally works with the definition of how time flows. Following this model, because time can't flow without something occurring here. I can't go backwards necessarily. Because say if this was flipped, say if I want to go from here to this way, right? If I want to go the opposite direction, if I wanted to do this, well, me doing that relating the area just flipped the power rule, ultimately. And here's a circle right here. You can see this is the exact circle that I'm talking about right here. It's supposed to meet here. It might be a little bit of variation, or maybe that's just visual, but that is it. This is the only time when the zeta function is, I mean, it's the singularity. Right? The zeta function can't be here at the 0 point, but it is at this point only when nothing exists anymore. When that area is 0. So it just doesn't work. I can't flow time this way properly because of how emergence and divergence, how the direction of this top end goes basically out toward you. Like this, well, no, other way around, sorry. This top end goes out and away from you. It shrinks. This circle shrinks. It's going as it goes. It's depth perception, literally within the 2D plane. Like I said, it's modeling 3D in 2D, and this is where things are funky as hell. Because if I integrate that into 3D, then I'm going to be able to model 4D from the 3D and model and measure 4D from the 3D just based off this hypothesis. And that's going to lend to solving a lot of things because we can relate local causality to the force that happens between things, that energy transfer. This is where energy is transferred between things, is when those two circles meet. So I think here, oh, it does shift. Oh, yeah, it's kind of cool. Cool visual. It does shift over. That is one, yeah, that's one way to look at it. But it just doesn't flow like that. Or at least we don't experience it like that. It more so just happens instantaneously, which is why, I mean, time doesn't, it can't flow in reverse. We can't do anything about that. We are stuck in a one-way loop. That is it. The only way to reset it is to just destroy everything. That's the only way it's going to allow that to happen. Right? And it's weird because it's maybe at that point when it gets to the halfway, this area relativity flips where we get that expansion. And maybe it's just, I don't know. That I don't know. Let me play the model like this actually. Interesting. Yeah, entanglement doesn't work. We don't have space anymore. It breaks going this way. To us, though, we don't experience this. We can't experience this because we'll be gone. Nothing will exist. So that won't matter. And in fact, maybe this can describe the anti-universe as well. But ultimately, this is at least the best description that we can have mathematically for why time flows. Because if I did things this way, I'm trying to divide by 0 because this circle's empty. The signs would have to flip. Well, not the signs. The numerator and denominator would have to flip. So how does that? It doesn't work. It just doesn't work. The flow of time is undefined when nothing exists. Because there's nothing to interact to define the flow of time. That is literally the whole point of my hypothesis. Existence equals truth over time equals negative existence or extinction. Because without truth, without things existing, time doesn't work. It doesn't exist anymore. It's 0. But that just breaks. That breaks obviously the equation. So then I guess a sign flip occurs. Relativity breaks. The vacuum energy breaks. The universe breaks. And in turn, everything that doesn't exist, all the quantum particles, basically photons, they only have one thing they can do, and that's just to recombine. Do that, that. Once we get past equilibrium, keep going. And boop, Big Bang. Equilibrium, things, the universe starts to cool. We get the slowdown. Now, to find out where we are in this timeline, I mean, what was it? About 13% of matter that we observe in the universe exists? Something like that. So it would be 13% of that area. Quite frankly, total is, I mean, relativistically speaking, that if I did it to A, what's half of 13? That'd be like 6. Would be, no, it wouldn't be 0.6 duh, because it goes up to, it'd be probably around here. That's the amount of space that exists right now. That's us. But on a good note, but even though we might seem to be toward the end of the universe, technically, it's going to take forever to get there still. Due to that step, I mean, the fact that everything in space isn't interacting. And ultimately, it's probably going to be giant AI that we create or us that ends up destroying the universe faster. Let's be real. Just like how, I mean, look at the planet. We destroy the atmosphere. We're basically cooking this whole planet anyways. And you cook the planet, you're going to screw with the core, and you're not ever going to be able to get a stable atmosphere ever again. I'm laughing now, but because I know I'm probably gonna be dead by then, but still, it's not good for my family, that's for sure. And that's why people take that shit seriously. So I know it's a lot of yap today, but it's been a while. Oh, an hour-long video. Lastly, I'm gonna go over the equations. So, like I said, I'm transforming. I'm trying to find the radius of that inner circle. I'm calling it interdimensional. It's probably gonna be extra dimensional, but if times 4D, technically that would be the interdimensional where force is transferred. So maybe I'm right, maybe I'm wrong. The nomenclature, regardless. So there's going to be two variations where x equals y, so on the 45 degree, and then using cosine and sine in order to cover everything else in between. As for non-abelian groups, basically groups outside of that closed circle, that's another thing that I have to figure out. I'm also going to have to figure out how to map polynomials to this, because that'll be huge if I can do that. But I mean, I could relate it to the degree of dimension, which is this is that n number that I was playing with earlier from Grant's video. That n number right here, the dimension. So if I go to 3 and I check things out, things get a little weird. Because at 2, you saw that circle was in between. That was fine. But now at 3, that's very interesting. That changes. The rate at which that fluctuates is relative to theta. And theta right now, go to theta mode, time animated, t equals 0.04 mod 2m, or 2 pi. So this is based off just 2 pi standard theta, right? Theta naught. Just your typical motion. Now I can relate that to this ratio here. That is interesting. Kind of that back and forth squeeze. It doesn't really touch anything, but it is getting smaller slowly. Do that and the midpoint's moving. See, we got this. I don't think it's doing anything right now. Unless, oh, wait a minute. The E value for that. Should be relative. Unless, oh no. Volume recurrence. Boom, boom. V to E, V to A. And factorial. I do not have theta in here yet. I don't think. I thought I did. No, I do not. That will be interesting then when I do put that in here. I'll change those. I think then, I guess, -1. Just flipped everything awkwardly. Did 1, doesn't do anything. If I did 0, it gets rid of that. Throw it via E. E is the one that's variable, by the way. And this is relative to A max minus A. We do A minus A max. It's the same thing. Two A max minus A. 2A max plus A. Then I also have 1 over A. Which you can kind of see the rate difference here. So you see how more quickly that opens and closes while this doesn't. There is that volume, that rate of change in the volume that's supposed to be in the center, I guess. 2A, that would be relative to diameter. At 2A or A doesn't really matter. Well, at least in this scale too. These are very small here. And it's as that circle shifts down and fluctuates, doesn't necessarily touch 0. So there's still a lot more I have to study on this too, but it's doing it. It's doing the thing. Fortunately, like I said, theta is not tied to this mode yet. But I mean, I don't really need it to be. I could just do. I mean, I do have the spinning circle dots, not just the imaginary numbers. But oops. PE. This was. Oh, that's why it wasn't even on in the first place. Yep, there's our pendulums. We have some that are static, kind of. Some that are static. They're being canceled. But ultimately, I mean, this one's just creeping away. Some of these are just moving slowly. Some of these are more rapid than others. Relative to V of E, so this one, static. There's one more that was changing. If I change, let's see, so let's tie to that now. This is VV, yep, this changes that. So it'll be relative to A, relative to 2A. Just changes the angle. One over A. 1 over A is perpendicular? Does that do anything when I move it? It does. What? What? No, it doesn't. Not really. Let me see. No, no, it just chills there. Keeps the diameter basically. Oh, there's plus minus diameter there. Okay. If it did that, oh, it's cool. 1 over A is the y-axis, A is the x-axis. Oh shit! That's relative to c of n times e to the power of n. C of n equals pi power of n over 2 divided by n over 2 factorial. Oh no, C of n. Yeah, that was different n. There's another C of n here, and this is E of n. Where, yeah, E in this case is not Euler's formula. It's not that number. E is the radius that I set here. So not to get that confused, because I know that can be confusing. But ultimately, is this 45 degrees? Two. This is definitely a transformation, or it's in between. What the hell? Yeah, there's still so much stuff that is involved with this model. If I change n to 6, it doesn't do anything. If I change n to 47 dimensions, it does do something. What? Whoa. Oh. 13, very unlucky. If I do to 12 dimensions. Well, wait, what? 12, 13. Well, this is also relative to, hold on, where this is. Undefined, yep. All the way over there now. Was there. Go to 2. Not moving. Maybe because we have undefined. Oh, no, it was that. I was looking at the wrong thing. It's just moving there. And now it's over there. So once I pass 12 dimensions and go to the 13, things break. 14 is where it flips again. 13 is very off. But then I have that? What the hell? Well, this is all 2M. Let me do 2A max. 2A does that. Does this influence? No, it does not. Go to large scale. It doesn't do anything. Then a 2. Interesting. Okay. The negative A doesn't do anything. 2A does. So multipliers do stuff to it. Then 1, negative 1. That ultimately doesn't matter that much. 1 over A. That does. Yeah, it's very interesting. We get all these different angles now. Based on dimension. I want to say this might draw out the curves that are on the outside, but I'm probably wrong. At 37, that doesn't matter. At this point, the scale is so immense that everything just converges to the x-axis or the y-axis. And then I have a circle out there with that. Where'd that come from? Hello? Excuse me. Let's do, what's 100 dimensions, right? This is the extreme of the model. It's barely gonna go up. Oh my god, unless it's the residue. Right, very interesting. Negative 1 over a doesn't do anything. Negative a doesn't do anything. A, nope. Nope. 2a, nope. A max, 2a plus a, nope. Nope. Yeah, it just doesn't. Which, I mean, ultimately kind of makes sense, too. Depending on how you think about dimensions. Honey, it has not been 3 hours yet. She got gas. You drink. Money of your bottle. Yeah, see, A and 2A, you have a deviation still. It's like the multiplier in the 2-dimensional and the 3-dimensional matters. Now, in 4D, God, I got so much shit I gotta do. I just wanted to share this at least. God damn. And also just explore more, because I haven't had time to even explore this as much as I'd want to. But this is interesting. So 1 over A shifts there. A shifts there. 2A doesn't shift anymore? That's very interesting. That is very interesting. Is that where interaction is limited dimensionally? Because 4 dimensions, it doesn't matter what I do here. Ultimately, the volume of whatever occurs between these two planes, it doesn't matter in the 4D, and that might also aid to explain time. Because this right here is exactly where that is. That is, it's the opposite, or well, not even the opposite. It is the radius of here, even though it's 1 over a, or well, 2a to be more specifically. If it's a, yeah, it's the radius of that. Is it always the radius of that? It is always the radius of that. Yeah, wow. So, oh, there. There is some influence there, though. Oh. That angle has something to do with something. That angle change has. That is representative of something. Because following the radius of that, but it's also defining more or less that time dilation factor, or the rate of change, because it goes from probably here we got a 45-degree angle almost, and then, or well, maybe not. Then it flattens out to there. If I did 1 over, I mean, negative a doesn't really matter. They both do the same thing, kind of. 1 over negative a, this is just that, but in the y direction. Is it? I think it is. I can't tell. Maybe the negative a doesn't work as well. No, it just stays. Okay. 3 dimension? Vary? It does. Wait, did it flip back over? Wait, what? No, it's there. Wait, what? Oh no, duh, because it disappears at that point. No, it doesn't move on the Y. Huh. Interesting. Okay. Yeah, well, I don't know. But if I have a chance, I guess I'll load this. I also want to check out. I hate that if I want to check anything out in the screen, I don't have a Python player or whatever. Gotta do all this shit. They could see max entanglement, where it reaches equilibrium, entanglement entropy, talking CMB, the change in the CMB. This is where you can see entanglement entropy starts to go down. Starts to go down a lot. Very interesting. If I hurry this up over here, oh, not that far. Yeah, it's almost immediate at that point. Yeah, that's where you get your flip. So I don't know, but I'll see what happens. I know those equations should model that radii correctly. I mean, obviously, friggin' already did the math for that. So I'll have those radii at least done, and I have names for each one. There's a lot of different names. So just like how I have E set up for A, I'm gonna have to have like R of E, re set up for all of these radii to be interchangeable in these general equations. So wait, not these ones. These general equations. These ones are like the ones that I was just showing you. Except even there's more because I have to consider scale and offset, and I have to also consider where scale applies to all of this. So thinking of like an equation of a circle and hyperbola, etc., the different scalar factors that are allowed, that do exist with these different things, as well as how to, well, not even just apply, but applying these scalar values correctly relative to my hypothesis, with at least the midpoints being equal, like that 45-degree angle of the timeline being certain. Because we are very certain of how time flows. We are very certain of our timeline. We're very certain of the things that do exist within it that we experience for the most part. Unless we're just too ignorant or too stupid to realize it. So, or too lazy to take the time to learn. So, with that, I was able to transfer those scalar values in such a way that they would affect the radii. So we'll be able to, just like with the different values of A that we have there, those same values I can use here. I can use interchangeably throughout all these equations and morph based on the change of A. I can morph that inner circle because that radius is going to be determined. That radius, all these radii are going to make circles within that radius. It's so much transformation, so much warping potential that it should explain a lot of things. And here I'm still working on obviously all of this. I do the trigonometric variance, relative to E, where I pull the radius, the typical radius, E5, on the outside as a scalar for the entire thing. So that's going to be interesting because sine theta, cosine theta both take the place of, well, they basically cover for when y does not equal x, right? They're the use case where I have a variable between them that is relativistic to those theta modes that I was putting out. And those theta modes are relativistic to the changes of a, the rate of change. So because that rate of change, we're able to drive that into these sine cosine functions. We can pull the radius out and make that into more so of a scalar if we want to. Again, this is just this is all a model for testing all these different ideas and to see what comes of it. And I also have my description of divergence. And this makes sense too, because when we look at, you know, the things that exist converging, diverging, different pieces out after the converging, space emerges. So following those fundamental definitions like we just went over, and I described them, and it does all coincide with how the universe functions. And moreover, finding the connection between these two areas as they are restricted by their bounds, obviously. Existence, I mean, we all together live with this. We all together live with possibility, impossibility, what exists and what doesn't exist. And what doesn't exist makes up the space around us, ultimately, because those interactions determine how much space over time is made. And that's dependent on possibility and everything else. All this stuff we experience every single day of our lives in this universe. So ultimately, the connection point for, say this, like I've said before, say this circle is E equals mc squared, all of E with mass. And this circle is energy relative to quantum mechanics. Energy, just energy in space, right? In different various forms. That might be E equals mc squared, but not really. Or it could just be free energy in the universe that ultimately gets pushed through photons and neutrinos. Basically, this is where the neutrino displacement theory starts coming into play. Because I mean, what else could this be? Because, well, I mean, it could be still be free particles in space with a little bit of mass, but I mean that mass is so negligible compared to the matter that exists. Maybe that's where the difference is. That I don't know. But regardless, what happens in between this circle that exists, that is causality. That is local causality, because in order for this to turn into this, things have to interact, and this is the way to describe that. And this will also connect possibility to impossibility, because when now that converges, again, when possibility converges with existence, this is where you get divergence. And divergence of extinction and impossibility, things that don't exist in that form anymore. And that dictates the flow of time in our universe. Ta-da. So I'll add more, and then lastly, I'll go over. This is so much stuff. I'm taking so much time. But I've been so long away that I have all this to explain. That is the model that I pulled up. All right. I have been weighing this, even in the early versions, with everything that's out there that at least Claude can scrape up, because Claude is a good compiler of stuff. Oh, you little peanut. Oh, ah, shit. All right, I got 15 minutes, not even. Anyways, I'll have to cut it short. Just know that this does have extensions to everything that already exists. It has relativity to everything that already exists. And whether it's because of the articles that I have had this compared to, or I mean, it's pulled things that I haven't even put into the project from the internet into this. And not pulling it, changing the fundamental model, or rather being able to measure these things using this model, which is very cool. So this is where, I mean, people can have their subjectiveness about all of this, but there definitely is some coverage. Unfortunately, this does not want to load. I could probably download this faster. All right, good. Bro, it's only 30 pages. It's only 30 pages. It is a lot, but my internet could just be bad. I don't know. I don't even know how this sounds. I don't know how any of this is working right now. I mean, summary, open physics problem, the complete 60 extension registry in full table form. There's 60 extensions from this model that apply to whether it's quantum mechanics, classical mechanics, mathematics, geometry, etc. Because by the end of the day, this is holomorphic disk comparison using holomorphy and concentric disks in order to measure everything. Assuming density, I guess, is infinite, which this is why it's important for black holes too. In fact, that whole center of local causality could explain a black hole singularity. It could explain probably the boundary where mass has to pass in order to become a black hole. Like, that's why this is important, because maybe that thermal equilibrium state might determine something there. But it does definitely touch on quantum mechanics, especially when using Kohn extensions in Lie algebra. The Riemann hypothesis spectral tower, which is fundamentally in here, using the inverse power rule, but ultimately there's some suggestions that were made by Claude that I'm gonna try out for sure, because maybe it'll figure something out. But ultimately, I mean, groupoids, algebroids, that using different instances. Excuse me. Hell, sure. Come on. I have it downloaded on my phone, so it's fine. I can load it anyways, and plus I already took pictures before. There are earlier reports that I've done, but for whatever reason, things are breaking. So maybe time to call it. But anyways, hopefully this was informative. Hopefully this gave you some insight, at least to what's going on. Grant, if you do see this for whatever reason, thanks, I guess, for coming to the same conclusions. Oh shit, where was the 3D model? I did want to show that because that literally is the same thing that he's freaking doing. Ultimately. I have it in the projects, but I don't have it here. It's just taking forever for whatever reason, because this is honestly very stressful on this AI. This whole thing has been very stressful on this AI. Check here. 2D. Oh, oh there it is. 3D. If it works, I don't know, things aren't loading. Oh shit, what's going on, man? Oh no. Well, technical difficulties. That's for sure. Can I download it? Why? Internal server error. Weird. It's 2D. I have the 3D right here. I have the code for it, I just can't freaking play it. Maybe inconsistent for sure. Of course. Yeah, it probably is. Probably why I can't play it. Oh man. Oh, this is the description that I made it. Yeah. Like, does this part work? Yeah, this is the initial where I got 50 different things. Could be index. Maybe not indexing. No. I am pushing things to the limit, aren't I? Christ. Inverse circles and sphere analysis. Isn't this not what I just clicked? Get apps and extensions. I probably should. Excuse me. Why can't you play any of my models? I'm gonna have to integrate that version to the 3D, I suppose. That was my next step, but I wanted to put this stuff into a 2D model first and then integrate the 3D. There's a 2D and 2D, 2D. This is me doing some fixing. So I was trying to do some stuff there, but it just wasn't working. I think I abandoned anyways. Hmm. I only had a 3D here, but it just, I mean, you see the name of it. It's the fucking 3D model, but it's not loading. I know the step factors I was working through. Yeah. Step factor 3D. Weird. Very weird. Could have been because I deleted some project files to save space, but you know what? Ultimately, everything's already documented anyways, and the current 2D model works very well. So, last thing, I didn't get to do any of the stuff that I was asked to do, and I'm gonna have to deal with some shit soon. Because I really wanted to get this out, because I have no time to do anything, because there's so much stuff. Shit. Is that? Where is it? Nope. Somewhere. Hide and seek. Ready? Oh yeah, this is the list of where things connect. So again, like I said, check out the posts. This is where you're gonna get most of the information as I get it. And here's the 3D spheres. Bro, I wanted the picture. I didn't want the whole fucking post. Or not. Okay. Real cool. Hell. The hell. There. All right. There. There. Yeah, because I literally addressed him. So right there, and you see those circles in the middle, those represent those unit circles, not necessarily the ones that I'm going to be programming in soon, which is relative to the difference in radius, depending on divergence and emergence. So, or which defines divergence, emergence through convergence, and distribution of force throughout space, which is energy. Oh yeah, this is a cool shape too. So a lot of cool things, man. A lot of cool things. You can get orbits, you can get ellipses, you can get eyeballs, you can get the squiggles, you can get friggin' bunch of stuff. I mean, just from the 2D plane alone, which is pretty cool. And I also haven't even put triangles in this bitch yet. If I put triangulation in here, I mean, it's, yeah, that's it. Triangles related to A. I can do everything related to A and then come up with this model just because of the difference between circles and squares and the fact that pi is probably the meaning of life. It's definitely the reason why life exists because it introduces primes because of the friggin' zeta function, and it also circles do. I mean, realistically, complete is the Ouroboros that eats its own tail, you know. But anyways, until next time, this is Sparks and Peace. I got shit I gotta do. Bye bye.